Hello everyone, thank you for joining us in this new webinar introducing new connectors. In this occasion we're introducing the connector to tNavigator via a rescue model. My name is Emilio Spinola. I'm a support and sales geoscientist based in Perth. Please note that this webinar will be recorded and uploaded into our website in the coming days. And if there are any questions, please feel free to ask them at the end of the webinar, and I'll do my best to answer them. So this is the agenda that we will have for today's webinar. Just a couple of slides, and then we'll go straight into the demonstration, where we'll spend most of the time for this webinar. Just to let you know that this webinar is part of a series of webinars where we are introducing all the features in this release, Petrosys PRO 2019.3. So we started a couple of weeks ago with a couple of webinars, and we're going to have another 2 webinars on this series. So if you want to register to those webinars as well, please go into our website and see the details of those webinars, and please register to those webinars as well. Just a quick graphic showing the latest releases, the timeline of releases that we have developed over the last couple of years. So as you have seen, we try to put out meaningful releases as frequent as possible. So in the top section of the graphic you have major releases, and in the bottom section you will have the minor releases. Currently we are in Petrosys PRO 2019.3, which was released on March of this year, and we are releasing today a minor release, which is mainly fixing some issues that we detected in the main release. So in this release, Petrosys PRO 2019.3, we have added around 121 individual enhancements, taking the total of the whole 2019 series to 280 enhancements. In this release, we are focusing in connection to third-party software, so we are adding to the already existing large footprint 2 new connectors: the connector to PalioScan and the connector to rescue model, which is the one that we will be discussing today. Just so you know, as I was mentioning, today we're releasing a minor release, Petrosys PRO 2019.3.1, which contains a series of fixes to a couple of features that we released recently. Petrosys PRO 2019, the major release of this year, is due to be released by the end of Q2, so sometime in June we are planning to have this release out. So please keep an eye on our website and our social media, and as soon as you see some information, please feel free to ask about that release. So what we're going to discuss today, which is a way to communicate or connect to tNavigator using a rescue model. So what the connector is in this stage, at this stage, is about to add support to wells data, 3D grids, 3D properties, and fault data for rescue files. So we're able to display them in Petrosys mapping and in the 3D viewer, but also we can incorporate this data in some workflows and in the surface modeling module as well. So we will discuss that in the demo, but you will see what kind of things we can do. And yeah, the rescue model is a way to connect to data coming from tNavigator, but from any other application that can export into a rescue model, then this connector will be useful as well. So having said that, let's go straight to our demo. So I'm going to start with a mapping window with a default map template and a dynamic extent, meaning that whatever I display in my mapping window, the extent will fix to the extent of the dataset. So we're going to start displaying some grid data coming from rescue models. So I go to display, grid, color field. So if you see now in data source, there is a new source rescue file, and that's the one that we're going to be using to display rescue grid. So once you select rescue file, you need to point to your rescue file, which in this case is this one here. So if I click in the little folder, it will take me to this one here, which is the binary file that allows us to connect to that rescue model. Once you do that, you will see that you have two options. You can select horizon and grids of that rescue model. If you select grid, you will be able to choose any of the properties contained in that rescue model, and then you will be able to choose any layer from within that model. In horizon, you will see the horizons that make up that model. So in this case, I'm going to choose this horizon here, and I will be displaying it as a grid. So I'll use just the defaults, just a display color field. Click OK. My extent changes to fix the data, and now we are displaying rescue horizon as a grid in Petrosys. Quick tip: if I click anywhere on the grid and hold my mouse and move it around, you will see that in the bottom section of your map, of my mapping window, there is a read of the coordinates, but also the set value. So it's a quick way to get a read out of here, right? If you want, for example, to export that grid, or you can do it from within mapping. So if you, for example, right click and select export grid at the bottom of that panel, you will see that you'll be able to export into a CDF format. So for example, if I choose Petrel and I connect to a Petrel project, I should be able to export right away from within mapping this grid into a particular Petrel project, or to any of the sources that we have here, right? So if we wanna export it to OpenWorks or Paradigm, it's the same procedure, right? So that's about displaying a grid. So let's say that I want to display some contours in this grid. I double click on my layer, go to contours. As you probably know, since a couple of years ago, we have the ability to display contours on the fly, so there is no need to have an additional contour file, right? So all we need to do is to enable this box here, display contours, and let's set some increment for those contours. So I'm going to choose a minor major increment, and I'm going to set this thickness to 2, and I'm going to put a label, and this size will be 10. So quick tip: I'm going to match the increment of the contours to the increment of the gradients to have a better display, and I'm gonna set some translucency of 30% here. Click OK, and we get something like this, right? So as you notice, the color field has an increment that matches the contour to have a better display. I have set some translucency, and also we now see the contours that are displayed and calculated on the fly, right? As with the gradient, if I click in any contour, hold the mouse and scroll around, you will see that I should be able to follow that contours, and in the bottom of my map I have a read of the coordinates at any moment, right? That's another tip of things that we can do. What else we can do? We can select a contour, for example, right click, and we should be able to save these contours as a contour file. As I said, there is no need to do this anymore because we are able to display contours on the fly. But if a user needs to work with contours for any reason, they should be able to save them from here just by right clicking on the contours and save them. We can also, if we select, for example, a closed contour, we can save this as a polygon. So in this case, I right click here, and I should be able to export to a polygon, right? So in this case, we have to give a polygon file name and a polygon name, and we should be able to save that particular closed contour as a polygon. So that's another thing that we could do in this scenario. So now let's display some well data from the same rescue model. So the same, go to display wells. In this case, I'm going to use the icon for display wells. So similar scenario, in data sources we have now a new source which is rescue file. Same principle, we point to the binary file from that rescue model, and we set some styling parameters like well symbols, wells annotation, path. In this case I'm displaying the full well path, and displaying the annotating the depth, and I'm setting an increment of 200, red color, and annotation free zone of 5 millimeters. Notice that we can also display well path segments if we have formation data, which is not the case here, but if we had, we can set different style for different segments, right? So let's click OK, and this is what we get, right? So if I'm zooming just to have a better look of how it looks, you see that now we have our wells, we have our surface location, our well path, and I have annotated the depth. So from the mapping point of view, there are a couple of things that we can do with these wells. So one thing, as similar to the grids and the contours, if I click the mouse anywhere in the well path and scroll around, you will see in the bottom section you have a reading of the coordinates and the measured depth along that well, right? So that's a quick way to have an idea of the measured depth around a well. So it's a quick tip that you can use to get that reading. We can also export the wells, and we can query the wells. So let's do some query of data. So if after selecting one well, I right click, I can select this option here that is called well header, and it gives me all the information stored in the headers of that well. So the location, the bottom hole location, coordinates, and any information that is being stored in the well model, in the well data from that rescue model. I can also query or check the directional survey data. So if I click here, you will see the plot, and you also can see the survey points for that particular plot and all the different data, right? If we want to query another well, there is no need to close these panels and select another well. We can do it right from here. So for example, if I select this well here, you will see that the directional survey and the well header data is updated automatically. So there is no need to close it. You just select a new well, and those panels will be updated automatically, right? So that's a quick way to query data. So let's close these ones here. So I was saying that we could export the well data. So let's see what options we have. If I right click here, and there is this option, export spatial data, and can export that spatial data into any of those formats here. I could export it right away. In this case, I'm going to export it to a shapefile, and I'm going to select a point shapefile, right? So I can populate all the other parameters I want. I will leave the default ones. So it's telling me, this panel, that it has detected that spatial data contains 23 points and lines, but because I'm exporting the data into a point shapefile, it only will be able to export the points from that spatial data set, which makes sense. So if I click OK, now that data has been exported into a point shapefile. So let's display that point shapefile. Let's select shapefile from my display GIS, and let's call that particular file, and let's select any point style. Let's make it green and a size, and let's choose a particular, this one here, this symbol, and let's click OK. And now you can see the well locations now in a particular shape file, right? So that's a quick way to export data from the well location data into a GIS file, like in this case a shape file, right? I'll show you later another thing that we could do with this shape file, but for now let's turn back the well data, and this is my map. Let's say that I want to focus on these structural highs in my grid, and I want to select an extent that highlights only this area. So we can use the tools from the map template functionality. So in this case, I'm going to repeat the map extend interactively. I select this option here, and I want to, let's say that I choose this one here. So this is my new extent of the map. Let's say that it's not quite right, so I'm going to pan my extent. So I select the pan extend option, and notice how the coordinates are moving because this is not the normal pan, it's actually panning through the extent. So let's leave it here, and let's pan it a little bit here. So maybe let's make it a bit bigger so I can expand the extent by 10%, something like this. Let's give it another try. So let's say that I'm pretty happy with this extent, right? So that's how you play with extents in order to set a new extent that reflects the information that you want to display. So now what is left to do is to set a style. At this moment I've been working only with the default map template, but if I select a style template from my list, from the style option here at the bottom right, you see that in this particular project I have a series of extents, style template. Let's select, for example, this one that is called PowerPoint. So you will notice that all the elements of my map, all the map elements are within the map area. So that's one of the options that we have to select the extent. We could change to another one. So for example, let's change to this style here. And yeah, that's pretty much my map ready, and I should be able to export it now to any format that I want to, or to a PDF if that's what I would like to do it. Just a final detail, I would like to add a color bar to this map. So I select my grid, right clicked, display color bar, and I go through the different tabs. I'm going to leave the default ones. I'm going to turn on the histogram of that particular grid, use a single color, and I'm gonna place it within the map area at the bottom left. Click OK, and I have my color bar, and I have a distribution of my data on that color gradient, right? So let's say that this is the final map, and let's choose another style that I have prepared as well. So similar style, but the location map is quite different, as it's using a dual UMS to locate this data in my location map. So let's say that my map is ready and I want to do a quick export of my map. If I want to embed, for example, this map into a PowerPoint presentation, there is this icon here that it will do a quick export. So if you have a PowerPoint presentation open, as soon as you click here, it will embed that map into your PowerPoint presentation, right? So that's an easy way of bringing data into a PowerPoint presentation. So that's easy as that. So that's from the mapping point of view what we can do with rescue data. There is one other thing that we could do. Let's say that, for example, instead of displaying one element or one layer from within the rescue model one by one, there is an option that we can display all of the data at once. I have already done it in this other mapping window. The way to do it is you go to display any data, you select the type of data that you want to display. In this case, it's a rescue data set. You select your binary file, and once you click OK, Petrosys will detect all the information that is stored within that rescue model. In this case, there is well data, horizon data, and up to 20 property layers, 3D grid layers that are stored in that rescue model. So if I click yes, In this case, I will not do it because I have already done it. It brings into the display all of the data is stored in that rescue model. So wells data, horizons, and grids, and save them or organize them into relevant groups, right? So that's a quick way to display everything that you have in a particular rescue model. Of course, it will take a little bit of time because it will read all of the data set and will display them, all of them, in your map. So that's another way of displaying data from a rescue or any source into your mapping window. So let's go now to see this data in the 3D viewer. So I'm going to my main launcher and I'm going to open the 3D viewer. So let's open a 3D file that I have already prepared. So it's in essence the same data that I was working with. So you see the grids and your well data. Everything is coming from the same rescue model that I was working with. So it's if I open your wells layer, you will see it here. The new source rescue file, and then you should be able to select the styles as you do in mapping or in any other source in the 3D window, right? The same with the grids. You select the data source, you select the model, you select the horizon or grid, and then you specify your the horizon that you want to display. Same principle as in mapping, but now within the rescue file. So let's say that I want to display some point data, the point data that I created when I exported the well locations into a shapefile. If you remember, that point data is in a point shapefile, but they don't have a set value associated to that one. So a quick way of doing it to associate a set value to those point data set is to do what is called a back interpolation. So let's go back to mapping window. And I'm going to do a back interpolation, which is sampling a particular grid into some point location, which in this case will be this shapefile here. So I'm going to right click and I'm going to launch the spatial editor by selecting edit. I'm going to select all the points that I want to do the back interpolation. So by drawing a rubber band, I see what points have been selected in my table. And now I'm going to operations. Okay, so I forgot to create an attribute where we're going to save the back interpolation data. So let's do it quickly. Let's go to layer definition and let's enable the coordinates include Z dimension. Okay, and let's save it. And now let's try again the back interpolation. Okay, let's again select all the points, operations, back interpolate. Let's select the source, which in this case is this rescue grid file. Let's point again to the rescue binary file. And the only attribute is the set value. Sorry, I forgot to select the grid, which is the top one, which is this one here. So what we're doing is we're going to sample that grid at these point locations, which is called the back interpolation process. As soon as I click apply, tells me that 12 values were updated, means that 12 values were sampled. Let's click close. So if I now click in these particular elements, you will see that those points that fall within this area have a set value associated. So that set value is coming from the grid, and just sample the grid at those well locations, right? So once we finish, we click save, we close it. And now if we go back to the 3D viewer, we can display that same shapefile and let's click OK, and you will see those green dots. So those are the well locations, and the set value has been sampled from the grid that we see here. So that's why those points overlay the grid in the right location. So that's one of the uses that we have for the back interpolation process. So from the well data, we export the well locations into a point shape file, and then we back interpolated the grid at those points location, right? So that's a quick way of sampling any data set in a particular grid, right? So let's go now to the surface modeling, which there are a couple of things that I wanted to show you as well. So I'm going to open a particular file that I have already prepared. So 3 quick workflows: the exchange of grid data, and tying your grid to a point location. So for the grid exchange, we now have the ability to exchange rescue data into any of these sources here. So for example, I can exchange the import data into Petrosys or exchange it to any of these third-party formats. So let's select all of here. I will import into a Petrosys grid file into this folder that is called Petrosys grid. So I leave the default ones as soon as I click OK. And if I go to my file directory, I go to the folder called Petrosys grids, and I see those grids have been imported into a Petrosys format, right? The other exchange that I have already set is the exchange from the rescue file into a Petrosys project, which I have already connected to. So if I select the same grids and enable the same parameters here, click OK, and if I now go to my Petrosys project and I go to the end of my input panel, you will see those Petrosys grids now appear here. So I took them from a rescue model and saved it into a Petrosys project by using the exchange tools in Petrosys, right? So that's another way that we can use Petrosys with this new connector. We have also the ability to create grid data using rescue data as an input. So I'm using that rescue horizon as an input, the same model, the same horizon. I'm selecting the output geometry from this particular grid. So I'm using data as to set my output geometry. Click scan. I can scan during task execution, and I can clip that data, the output grid. I can clip it using a polygon to clip the data, and that polygon can come from anywhere. In this case, I'm using a feature class called boundary polygon that is coming from a particular file geodatabase from Nestle. And to show you that particular geodatabase in RMap, I'm going to display it here. So this is this particular geodatabase, which is called Rescue Webinar, which contains only one feature class, this boundary polygon here, and this is the one that I will use to clip the output grid that I'm creating, right? So once I finalize setting all the parameters, I click OK, I run it, and it has finished. So if I go to my mapping window, and if I set the extent to dynamic again, so I have all the data in my map, I should be able to display that grid that I created, but also the boundary polygon directory from the file geodatabase. So go to display grid, color fill, in this case it's a Petrosys grid file. I right click, the data modifies, so it should be this one here. Click open. Let's turn off the contours and the color fill. Let's remove this one here, and this is the grid that I have created, and I have clipped it using that feature class from a file geodatabase, right? So I can also display that polygon. So if I go to display GIS, set the data source to file geodatabase, and I will point to that particular file database, which is called rescue webinar. It only has one feature class, which is boundary polygon, and let's change the style to make it more obvious. And now you see this is the boundary polygon, the feature class from a file database that I used to create a new grid using rescue data as input, right? So pretty straightforward. So the last thing that I wanted to show you from the surface modeling point of view is that we can use also a rescue file as an input to create some tied grid to a point data set. In this case, I'm using an Excel spreadsheet. So if I open this file here, it's showing me that I'm using these point locations stored in an Excel spreadsheet, and I'm going to use that grid, and I'm going to tie the grid to these points here, right? So it could be well data, but in this case I'm using a GIS file. So any point data saved in a point or well data can be used to tie my grid and to get a tight grid as a result, right? So I can set some reporting. So in this case I'm going to have some visual reporting and some numerical reports. Once I'm ready, I click OK. So this is the visual report, and this is the numerical report where I can see how effective that process went. I click OK, close this one, and let's display this in the 3D viewer. So let's go back to my 3D viewer. So first let's display the point data. So I'm going to replace this shapefile for the Excel spreadsheet that I used to tie my grid, which will be this one here. So these are the values that I want to display, right? So if I select here, let's change the set values to edited set values. Let's click OK, and let's click OK. So this is the set values that I use to tie this grid into my tie grid, right? So if I now display that grid that I created, which is the tie one, this one here, let's display in a single color to make a difference to the original one. And this is what grid. This is the original grid. This is the tie grid, and I've used these points in an Excel shapefile to tie my rescue grid and to get an output grid that is tied to those one locations. So that's all I wanted to show you today. So if we go back to the presentation, please remember to check our client portal, where you have access to a lot of workflows in PDF and short video formats. And also please feel free to contact us at support@petrosys.com.au for any questions. Thank you, and don't forget to register for the follow-up webinars from this series. Thank you.